In this video, we're going to talk about drawing the Lewis structure of I3, right? The iodide ion. So the molecular formula is I3 minus. So how do we come up with the Lewis structure for I3 minus, right? I usually like to put down the amount of atoms, the quantity in the atoms that I have, and then their valence electrons. So in this case, I have 3 iodine atoms, right? And then I'm going to go to my periodic table and see that iodine is an halogen, and then all our halogens, they have 7 electrons in their valence, right? So I have 7 electrons in my valence, right? So what's the total amount of electrons that I have? Well, 3 times 7, that's simply 21. But remember now, here's the trick. I have a negative charge here. So that means that in chemistry, whenever you see a negative in terms of Lewis structure, that means that the compound has gained 1 electron. And so what does that mean? Right? That means that the 21 that I counted, which is 3 times 7, I have to add 1 to that. So that means I have 22 electrons total to place. Right? So the trick now becomes, how do you come up with the formula for it? Right? Well, I'm going to place an I. I have 3 I's. Right? So let's place them separate apart. Right? I know that in my molecular formula, I have to form at least a single bond. Right? With most of these problems, I have to form at least a single bond, and that just means that 1 electron from this iodine atom is sharing one of this electron is electrons from this iodine atom, and this electrons from this iodine atom, forming a covalent bond. And it's the same thing. So let's count how many electrons we've placed thus far. So we have 2, 4. Well, we have 4, but we still have 18 more to place, because remember, we have 22 total electrons. Right? Now, iodine is one of those atoms that has to satisfy the octet rule. Now remember, in ions, when we talk about ions, the octet rule kind of varies a little bit. So when we talk about ions, sometimes the octet rule kind of gets kicked out of the door. So sometimes you might see atoms or elements that you expect to have the valence, have an octet rule, must have an octet rule. It can be expanded in some case or not expanded in some case. Right? So let's form our octet for our outer iodine atoms. Right? And so in this case, we have 2, 4, 6, 8. So this iodine atom is satisfied, and we have 2, 4, 6, 8. So this iodine atom is satisfied. So how many electrons we've placed thus far? Well, this is 2, 4, 6, 8, 10, 12, 14, 16. Right? So we've placed 16 out of the 22 electrons that we need to place. So where does the other 6 electrons, so where does other 3 pair of electrons go, or 6 electrons go? Well, this iodine atom is satisfied, this iodine atom is satisfied. However, we have 2, 4, right? So we have 4 valence electron in this place, and so in this case, we have no choice but to put the additional 3 pairs of electrons on the central atom. Now remember, this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And you will see that I've made a video about formal charges, but you will see that when you do the formal charge of the central iodine atom, it will have a formal charge of -1.